Morning students, welcome to online class. On continuation of our AC motors in C18 scheme EE503 starters and speed control of 3-phase induction motors. Today's session regarding to working of rotor resistance starter with the diagram. My sincere thanks and courtesy to all authors for sharing their valuable materials in the internet for the sake of students. Let us recap what we've seen in previous classes. We have seen the direct online starter. So this can be used for full voltage at the time of the starting. That's why it is limited to the less than 5 HP squirrel cage induction motors. An auto transformer starter also we have studied. In this case, we are going to reduce some percentage of the resist voltage initially, and star delta starter. In this case, we are going to reduce the voltage 1 by root 3 times during the starting, and so we are going to reduce the torque also 1 by 3, current also we reduce by the 1 by 3 times. So these 3 starters are used for both squirrel cage as well as the slip ring induction motor from stator side control. So whereas we are going to control starting current or voltage with the help of the rotor side, that is only possible with the help of our slip ring induction motor. In this class, we are going to study how we are going to control the stator current with the help of rotor resistance. Okay. So dear students, already we have seen everything regarding to the starters. What is the purpose of starter? So what will happen initially? Why it is current is coming 5 to 8 times of the full load current initially, and circuit diagrams already we have seen in previous classes. In this class, I am going to directly how we are going to control the starting current with the help of the rotor restart. Okay. So what are the objects today? So on completion of this topic, you would be able to know about the rotor resistance starter working with a diagram and rotor resistance starter current equations. Okay. So first of all, known to unknown. Do you know the rotor resistance starter? Do you know the rotor resistance starter connections? Which starter are used for squirrel cage induction motors? So what are the starters generally used? What we have previously discussed: dual starter, auto transformer, star delta starter, generally used for 3-phase squirrel cage induction motors. Which starters are used for slip ring induction motor starter? In this case, we are going to study rotor resistance starter. Okay. So we will see one by one. Previously, we have seen, at a glance you can see what is the squirrel cage induction motor and what is the slip ring induction motors. So the starters we discussed here. This can be used for squirrel. This is the 3-phase squirrel cage induction motor. Our special and today hero is a squirrel cage induction motor. In this case, I am going to use the rotor resistance starter. So you can see this is the slip ring induction motor. Okay, there is a three slip rings on the rotor, and rotor is also wound similar to the stator winding. So, this is taken out from the by using the brushes placed on the 3 slip rings. The brushes can be easily lift and we can place on a 3 slip rings. Okay. So, what is the function of the rotor resistance starter? The function of rotor resistance starter. In rotor resistance starter, the motor is applied full voltage on starting period. This rotor is only used for slip ring induction motors. It is not possible to use in squirrel cage induction motor where there is no slip ring provision is taking place. You can see the slip ring induction motor at a glance, the physical figure. This is the slip ring induction motor. So, what is it? So, these are the 3 slip rings, and here we are going to provide the brushes from outside, and from this is the input 3-phase input supply, and this is the wound rotor. So, this number of poles is similar to the stator poles, automatically it formed. Okay. Now, so what is happened? If it is 3 slip rings are shorted, it becomes nothing but a squirrel cage induction motor. If initially it is shorted, all winding stator and rotor windings is a star connected. Okay, we will see in that one. Okay, you can see, you get a glance. What has happened? For example, if you take the okay, this is a stator winding, wound on this one, and we have given 3-phase supply. Then what will happen? Here there is a rotor. In squirrel cage, the rotor bars are short circuited. In case of our slip ring induction motor, so it is also 3-phase winding wound on the stator slots, and it has also rotor, but it is a rotor has a winding, 3-phase winding. This windings 3 phases connected inside, taken outside with help of the slip rings. But here is a short circuited. Here is there is a possible to add this one. In this case, I am going to add some resistance initially. So, I can add some resistance in this rotor winding. Once 3-phase supply is given, it is also flowing current. That current is equal to I1 current. This is also flowing current is equal to I1. So, the current which is produced in this is called I2 current. Here also the current is the I2 current. Here the I2 current can be limited with the help of our resistance, but there is no provision is provided in this case to insert the extra resistance in the rotor circuit. Okay. So, what we have done is to limit the current. What is the relation? We know that I1 stator current is equal to no load current from the vector diagram, vector sum of this one plus I2 dash, the rotor current referred to the stator. So, this current is very high because it acts as a short circuited secondary of transformer. If rated voltage is given here, so the current which is produced, So what we have seen in previous classes, I2 is equal to, just like it is a S into E2 by same R2 whole square plus Sx2 whole square under root. That means here the secondary act as a just like short circuited secondary of transformer. This is equal source and this is a R2, this is a Xx2, this is a SE2 source. Due to this one, what will happen? So here the resistance short circuited, we applied the rated voltage, it will draw some more current. This current is nearly, so the current is nearly how much? So the current is a 5 to 8 times of full load current. So what is the full load current here? I1. I1 under normal full load applied on the motor, suppose example it will draw the, for example 5 amperes. But at initially, so due to the high voltage, the speed S is equal to 1, slip is equal to 1 and rotor speed NR is equal to 0. Due to this one, so it acts as a secondary of transformer, it will due to the rated voltage, it draws a more current, the I2 will becomes the more, if I2 becomes the more and automatically I1 also becomes the more, this will becomes to the 5 to 8 times current drawn from the supply. This is a unwanted thing, hence we require to limit this starting current. So we are going to provide some assistance here. Traffic police is provided to control the current, that is known as a starter. So the starters are dual starter, star delta starter, auto transformer we have seen from the stator side. Now in this case, so we are not unable to provide any resistance the rotor side, hence we are going to this side. So in this case there is a provision to provide the starter at starting side and there is a provision and rotor side also. So both side we can control the in slip ring induction motor. Okay. So for example with 3-phase slip ring induction motor, okay, slip ring induction motor, we can control, we can provide the constable here, or if you don't want here, then you can control the constable here to control our motor starting current. As not only this rotor resistance, so help to pick up the starting torque also. This is a benefit of slip ring induction motor. So while you are controlling, inserting some resistance initially as we calculated or previously derivation also, that means the starting current, the starting torque so depend upon the rotor resistance. If rotor resistance is more starting torque pickup will be more. That can be possible in case of slip ring induction motor where we are going to connect the starter at rotor side. At the same time, not only starting torque, it can be used to control the speed also. Speed control also we can use this rotor side. These are the benefits as comparing to the squirrel cage induction motor. Okay, so let us see how this starter, rotor resistance starter, what it consists. Nothing but, so here I can give at a glance. Okay, so what is happened? So here this is a stator winding. Okay, so it is for example we connected the delta. The stator winding is connected here. Now this is the rotor winding. Rotor winding also this 3-phase winding. Okay, so from this one we are taking the R phase, Y phase and B phase taken, and from the same shaft I am going to provide the slip rings. The slip rings connected such a way that here input. Then we are taking the output from this one and I am going to connect some resistance here. External resistance connected and this is connected here here and here. That means I can change the resistance value here, variable resistance, by using the knob. Then what will happen? So this winding has some resistance. For example, you can take the resistance R1. Now this resistance also having the R2. Then what will happen? Resultant resistance of the rotor circuit is equal to R1 plus R2. So due to the R1 and R2, rotor resistance increases. That means here, instead of short circuited in secondary, where is that one? Yeah, here instead of this R2, here R1, so we are going to add some external resistance here. So what will happen? Instead of short circuited, I connected secondary with some resistance here. Then what will happen? Automatically the resistance ohmic value increases, then current value decreases, I2 reduces. This is a basic concept, simple Ohm's law. Here what is happen? So rotor resistance increases, this is the I2, then if it increases, this will decrease. So if continuous contains this high resistance value, the current continuously flows to this resistance value, more power loss may be occurred. So what we have to do? So we can use this external resistance starting only till my rotor picks its 80% of its full load speed. Once my rotor picks up to the near 80%, then whatever the slip value, so decreases from 1 to nearly some percentage, 0.2 or to 0.4%. That means the speed, our rotor speed. For example, P is equal to 4-pole machine into NS is equal to, so 1500 RPM. Then it will try to normal speed rotor is equal 1440 RPM. For example, let us assume. Then once by adding my resistance in the rotor circuit, it picks up the speed. Once speed is increased to up to 1200 RPM, okay, nearly 80%, then I can remove this external resistance, this one. Simply I can short the slip rings here. What will happen? So whatever the rotor winding is taken outside is simply connected here, shorted. Then only resistance presents in this winding resistance, not this resistance. So this is the concept of rotor resistance. Okay, so resistance we will see that in details. This is the basic circuit concept. Okay, so let us see in our PowerPoint. This is the slip ring induction motor total arrangements. Okay, this is the stator side connections and this is the rotor side connections. Everything is similar. Now here I am not connecting any starter here. I am not connecting starter. Simply I will give the supply here, simple protection. Then I can connect here external resistance. Then how we are going to connect it? You can see this is the another figure. You can get the good idea. So what is it? It is a rotor winding, 3-phase winding, R phase, Y phase, B phase winding. So these windings star connected, the other terminals connected through the slip rings. From the slip rings it is connected to the here external resistance box. Okay, so what is consist? It consists of the resistance R phase, Y phase and B phase is consist. There is a common knob is provided here to change the resistance value. Initially the resistance value is a maximum, that may be the start position. There is a knob is provided here from the start position and run position. You might observe in our laboratory. Okay, so initially what will happen? So it is connected in start position. That means whatever the resistance value in each phase is a maximum connected in series with our rotor winding resistance coil. Okay, so this is the arrangement. So if you want to see the total arrangement, this starter and this one in a standard manufacturing machines, you can see it, how it will looks. So this is the one standard slip ring induction motor. Okay, so here starter also provided here. Okay, so this is a stator and here is the slip rings provided. So everything in the common this one. Okay, so if you want to see the what is the internal diagram, because we are the electrical students, we want to know that only circuit diagrams. If I know the circuit diagram, I can easily analyze my machine performance. Okay, so let us enter into our motor. How the slip rings connected with this I resistance connected in externally, and whether our motor stator winding whether it connected in delta or star. Let us assume this winding stator winding is connected in star. Then so our rotor also connected in star. Then how we are going to connect the resistance in the circuit? Let us see. Okay, so you can see this is the one circuit diagram, rotor resistance starter circuit diagram with stator and rotor with external rheostat. Okay, so dear students, so this is the stator side. So we are going to give the three phase supply IC TP switch. So once it's connected to the IC TP switch, it will try to draw the current I1. But what will happen in rotor circuit? I connected through the slip ring, the brushes to the resistances here connected. So that means here what will happen? Here you can observe that this is a transformer connected, primary transformer. So this is the secondary transformer connected. Now here resistance is connected, high resistance here. That's the low. Instead of short circuited, you connected to some resistance value. Then what will happen? So this current value I2 will decrease due to the resistance. Then whatever the I1 current, that is depend upon the I2 current. So as we have seen in vector diagram, I0 and I2 dash. Okay, so resultant of current is the I1. Okay, so that is the vector diagram. Already we known this thing. Based on this one, the I1 vector sum, the I1 is equal to the I0 plus I2 dash. The current is referred to the, this is the I2 current and referred to the primary side I2 dash. Then so we are going to get it I1 current. Okay, now the I2 is limited with help of my external resistance here. Okay, so what is the operation? You can see it. What is the operation? The stator current can be limited by introducing a variable resistance in the rotor circuit. First point. What is happened? The stator current can be limited by introducing a variable resistance in the rotor circuit. In this way, the starting current is reduced. So, a variable star connected rheostat, you can star connected rheostat is connected in the rotor winding through slip rings, and full voltage is applied into the stator side. So, whatever the three phase supply is applied here, full supply applied here. Okay. So, this is the arrangement. Okay. So, now you can see the, if you want to see it, what will happen? Operation we will see. Okay. So, concept we got it. What we have seen? So, here the stator current can be limited by introducing the variable resistance in the rotor circuit. In this way, the starting current is reduced, the variable star connected rheostat is connected in the rotor winding through slip rings, and full voltage is applied to the stator winding. Then the current is limited with the help of the I2 dash. Okay. So, now if you want to see the what is the physically appear rotor rheostat in our laboratory to start the MG sets. Dear students, you can observe this type of the rheostats in our laboratory for starting the MG sets, motor generator sets. The large machine can be started with the help of the rotor rheostats in our laboratory. Okay, you can see that figure also. So these are the different companies manufactured slip ring induction motor starter. Okay, so this is the standard one. So olden days, before, so nearly 30 years you can use this type of the starters in our laboratory, DC machines laboratory or machines laboratory. So this is the latest one. So provision with the different protection systems with help of this one. Okay, so main it consists of the oil inside to limit the sparking contacts, everything. Okay, so if you want to see the what is inside, how you are going to control this thing, so we can see inside the circuit diagram how our slip ring rotor connections is connected, rotor contactor, and this rotor resistance starters, how it will changes, and at the same time it is also provided with the overload protection similar to the OLR, and no voltage coil also we can provide. Okay, if you want to see the circuit diagram, let us connect this one in our circuit diagram. So this is the protection of our slip ring induction motor. So from this is the stator side, from this is the rotor side. The relays is the overload relays. Whenever the motor under overload condition or any short circuit inside the winding, it automatically cut off the supply to the motor. Okay, the stator contacts are operated with help of the no load coil. Everything similar to the previous starters. The minimum protection is provided for each motors. The main concept is here how we are going to connect the rotor rheostat resistance to our rotor inside the slip ring induction motor. You can see here at a glance. So here what will happen? It is connected one contactor here. So initially what will happen? It is connected in star. So the contactors are open. Now initially the contactors are open and it is connected with this resistances inside the resistance box. Or sometimes we can use the magnestrot inducer also. Instead of resistance, I can use the magnestrot inducers. Some winding also we can use. What is the ultimate? I want to create some ohmic value. A ohmic value I want to create. So I can use resistance or I can use the inductance value. Okay. Previous we have seen that is a resistance value. So resistance value I can use, instead of resistance value I can use this inductance value, ohmic values. So that is also produces as of ohmic value. If ohmic value increases, the current decreases automatically, I2. Okay. So this is the one circuit diagram. Let us see the operation of this one. Operation of rotor resistance starter with the help of the resistance. Then you can see the external resistance is inserted in each phase of the rotor circuit through the slip rings and brush assembly. Okay. So what is happened here? The external resistance, where is the external resistance? This resistance. External resistance is inserted in each phase of the rotor circuit through slip rings and brushes. You can see the brushes here. Okay, everything is connected in series. Initially, the resistance is kept its maximum value. So here the jockey should be the maximum resistance, that means here. So whatever the resistance here, so our jockey position should be placed because 3 is resistance connected in star. So what is the maximum value? You have to keep here. That means every OR phase here you have to keep here. That what will happen? Whatever the current comes, so flows here and will flows here. That means this resistance and this resistance added, the total resistance is called 2R initially. Okay, that is the main concept. Initially the resistance is kept to its maximum value. This reduces the rotor current. So automatically whatever the current I2 comes reduced due to the 2R. Both friends are added here, which consequently reduces the current drawn from the motor from the supply. Stator side, the I1 will reduce. What is the relation? So I1 is equal to I0 plus I2 dash. Now I2 dash, the secondary current referred to the primary, I2 is reduced due to the resistance value. Here Rukmini is increased, Satyabham is reduced. Okay, that is very required. Same thing, the external resistance is inserted in each phase of the rotor circuit through the slip rings and brush assembly. And second one is initially the resistance is kept to its maximum value. This reduces the rotor current, which consequently reduces the current drawn from the motor supply. That is whatever the current is taken from the supply is reduced with effect of this one. Okay, so that is and not only this one, and as the motor pick up speed, now initially resistance is very high. Due to the resistance very high, I2 value reduced. This I2 value reduces, this less current is enough to produce the starting torque. The torque is enough to rotate our rotor. If the rotor rotates, the slip value decreases and rotor speed increases. If the rotor speed increases, then what will happen? So it reaches to the nearly 80% of its rated speed. Then what will happen? So whatever the inside slip value decreases. If the slip value decreases, the EMF induced in the rotor circuit also reduces. If this affects the limits the stator current. Okay, so as the motor picks up speed, the resistance is gradually cut off. You have to remove. So what is the position here? Initially the resistance is here. So if the speed increases, you have to go slowly, you are going to reducing. Once it reaches to the nearly 80% speed, then what will happen? Here the resistance, all resistance coming here. Okay, jock is coming here. That means whatever the current is coming here, it is going here and it is going here. That means whatever the resistance is bypassed in this case. Once the speed is reaches to its 80% of the rated speed. Okay, when the motor attains the normal speed, the rotor windings are short circuited. We can short circuited, or we can short circuited the slip rings also itself. Through the slip rings and the brushes are lifted. It is a upper lifted, disconnected. The operation may be manual or automatic. We can control this automatic or manually. Okay, this is the basic concept of operation of our slip ring induction motor. Okay, so dear students, don't confuse. Simple, this operation is very simple. So as the motor picks up speed, what will happen? The resistance is gradually cut off. When the motor attains the normal speed, the rotor windings are short circuited through the slip rings. There is a mechanism and the brushes are lifted, disconnected. The operation may be manual or automatic. So that means, so this method not only limits the starting current I1, but also increases the starting torque due to the rotor resistance. So already previously we derived the equation. The starting torque is dependent upon the rotor resistance. Once initial resistance added externally, so with the help of our rotor you start, then starting torque also increases. That means pickup initially increases. So where we require that type of the applications, we can prefer these slip ring induction motors. For example, in case of the lifts, hoists, so where initial torque is required, pickup is required. Under normal running condition, no need the torque, but at the initially it has to starting torque is required. as I explained previously. So, in case of the Chetak, in case of our bike, so we have to apply the first gear initially only. So, at initially we have to apply the gear pass, gear 1, then we have to move it. Otherwise, if you are keeping the fourth gear and initially itself, what will happen? The motor will stop, our vehicle will stop. Similarly, here in this case also, the starting torque where we required more, we can prefer this slip ring induction motor instead of squirrel cage induction motor. The slip ring induction motor is similar to our series DC motor. You know the what is the DC series motor. Okay, so that is the similarity. The starter is not suitable for squirrel cage induction motors. That means here what will happen? So, here for example, dear students, just assume that this is a boy. Okay, so he is a boy. So, this is a girl. So, what will happen? So, I am going to give the some flowers. So, I am going to give the some flowers. So, this flower, she can use it, but what is the need of this person? He cannot place any flower in head, but whereas the girl, she can use this flower here. That means our rotor rheostat can be used. So, this can is a squirrel cage induction motor. This is a slip ring induction motor. So, this rotor rheostat starter can be used only for slip ring induction motor, not for this our slip ring induction motor. So, there is no slip rings here, there is no winding in the rotor circuit. Simply whatever the bars, rotor bars is inserted, copper bars are inserted and braced, welded here at both sides. There is no winding here. Okay, so that is the second point meaning. Okay, so these are the basic operation of slip ring induction motor, starting with the rotor rheostat. As usual, so this motor also protected from the overloads, protected from the under voltages. So, how this arrangement will take place? So, different companies has a different method of connections. So, you can see one arrangement of automatic starter with the help of the rotor rheostat to our slip ring induction motors. So, you can see this is the automatic all mechanisms as we discussed in previous classes. Here it has a slip ring induction motor, the terminals, this is the stator side, this is the rotor side, you can observe it. Okay, stator side and rotor side. And so, here how we are going to control the all mechanism, protection mechanism is provided, and start and stop green button, red button also provided, and this is the studs also provided for moving the to cut up the resistance once the speed increases in the rotor circuit. Okay, so these are the total circuit diagram. Dear students, you can easily understand this circuit diagram, but it is not in our syllabus. Okay, so if you want to see this one in a previous case, so how this arrangements in a physically, you want to see it, then you can. So this can be different companies, Crompton Greaves, and different companies may have the different configurations. You can see that figure also. This is the total arrangement, all protections to our slip ring induction motors. Okay, inserts, everything is provided here. So all contactors, no load, overload, star, delta, everything is connected here. Okay, so these are the small topic regarding to our slip ring induction motor starter. Okay, let us summarize what we have seen in this class. So we have discussed about rotor resistance starter function, diagram of a rotor resistance starter, working of rotor resistance starter. Okay, dear students, this is regarding to the starters. Okay, so now we have end of the starters in the chapters. Okay, so let us discuss in next class what is the next topic. Okay, So here, so we have discussed in starters, direct dual starters, auto transformers, and star delta starters. Okay. So at a glance, you can see the comparison between this one. So what is the comparison here? You can see it, or you can we'll go that here. So up to we have seen what we have seen. First, starters. What is the starter? In starter, we have seen the DOL starter, direct online starter, and auto transformer starter, and star delta starter. And today we have discussed in the rotor rheostat starter. Okay. So these are the starters we have discussed. Now, so we require to compare the few starters. Let us compare this one. Okay. So here I am going to compare, one is the DOL starter and auto transformer variac and star delta starter. Few points. What are the points? So first point 1, that is equal to, in dual starter, full voltage is applied here regarding the voltage. Full voltage is applied to the motor at the time of the starting requirement. No voltage control here. Voltage and I is not controlled here. Okay, but we know that OLR and no voltage, low voltage, no NLR is provided. Here auto transformer, what will happen? The starting voltage can be adjusted according to the starting. Auto transformer we can adjust it by changing the its rheostat position. X value, X square value we are going to control here. So voltage is reduced initially. So here in this case, so as we know that nearly the winding, each winding gets only 58% of the voltage. That means that is the 1 by root 3 times of the rated voltage we are applied initially at the time of the starting. Before it rotor reaches its 80% of its speed. That is the first point. That means here dual starter we are not control the voltage or current, and in this case we are going to control the fraction of voltages, and in this case we are going to control the 1 by root 3 times of the voltage initially. So that is why we are going to limit the starting current to avoid the inrush into the 5 to 8 times of the full load current. And in this case, due to this one second point, in this one the starting current nearly, so what will happen? We are not controlling, so 5 to, so nearly 8 times the current will comes in the percentage. But here what will happen? We are controlled, the starting current can be reduced as we require it. So because based on the our control, so starting current is reduced, I1 is reduced here. In this case, so the current I1 is reduced to the 1 by 3 of the direct current. That means 1 by 3rd of 5 to 8 times starting current. So in this case the starting current is reduced by 1 by 3rd. In this case we can control as is required, but based on the percentage of movement in the winding for the auto transformer ratio. Okay, that is another point. And coming to the third point here, the only 3 wires are to be brought out from the motor. Here what will happen? Stator, we are going to R phase, Y phase, B phase. Rotor is the slip ring induction motor. Okay, whereas the auto transformer also we are going to take it the 3 wires only. We are connected the 3 auto transformers, input and output. We connect the input and output. Okay, so only 3 wires are to be brought out from the motor. In this case star delta, what will happen? So 6 wires we are going to connect. So this winding, this winding, this winding. So start S11 and 22 we have to take it. So we have to connect the star initially, after that it has to connect the delta. So that arrangement is required. That means 6 wires taken out from the stator. Here 3 wires taken out by the stator and 3 wires taken out the stator. Okay, so that is the another factor. And fourth factor is a very important, that is the cost. The cost point of view, it is a very less cost. We are not providing anything here. So simply we are protecting the normal OLR and no load coil. So that's why it is limited to the less than 5 HP motors only. But in this case, this cost is high. So here we are going to use the external rheostat. And whereas in this case no cost, so cost also low. Simply we are changing the terminals star to delta manually or automatic. Okay, cost is low here. And another point 5 is equal, that is equal here. So operation is very easy here. Simply pressing the green button, motor will start. By pressing the red button, motor will stop. If any overload occur, if voltage below the rated voltage, then automatically take care of by OLR and no voltage coils. So in this case what will happen? So not so easy to operate. We have to operate the variac knob. So a skilled operator is required to start the motor. Okay, skilled person is required. Operation, so cost related to the maintaining of the skilled operator. Here what will happen? So the operator also is required. He has to move initially start the delta start connection. After that, when it reaches the 80% of the speed, then we have to move it in delta connection, or otherwise we require to use the timers. Okay, so in this case not so easy to operate, since the connections are first to be made in star, then in delta, either manually or automatically. That's why, so we are going to use a timer here. So timer will take care of it. Initially it will connect in the star. Okay, then after 5 to 10 seconds it automatically converted to the delta by using the some switch arrangements. So that's why it's a some skilled person is required if you operate the manually. Okay, otherwise we can use the automatic. So finally, so another difference is the one. So it can be always used for less than the 5 HP motors only. So we are not controlling the starting voltage or current. So here we can use the auto transformers. We can use for only large motors. So very costly. That's why we require the large motors. And so star delta starters also limited to the up to, we can use the 10 HP only. Okay, so 1 by root 3 times we are going to reduce the voltage. So that's why we require 10 HP only. Okay, so dear students, so these are the some relation between the D-volt starter, auto transformer, star delta starter. Okay, clearly I think these are the starters completed in this session. So next we are going to learn the speed control of induction motors. Okay, so thank you listening my class, dear students.